think you'll all agree that troubleshooting engine performance and starting troubles isn't the easiest job in the world. Many engine performance complaints are downright tricky to track down. That's because some ignition troubles have a nasty habit of acting like carburetion problems, and some carburetion problems act like ignition troubles. Now, to complicate things, some mechanical conditions cause performance problems that are easily mistaken for carburetion or ignition. This session is mostly on carburetion, but Steve here has some common sense ideas that should help us all to do a better job of telling when to suspect the fuel system and when to keep our hands off the carburetor. Isn't that what you have in mind, Steve?
That's it exactly, Tack. I was just telling Tom that troubleshooting is diagnosis by the process of elimination. There's several ways to go about it. For instance, there's the parts changer method. You simply replace parts until the trouble is corrected. I suppose the parts changer figures this is the process of elimination, but it isn't very scientific, and it is apt to be mighty costly to the customer. More scientific, but not very practical, ignore the symptoms and test everything. That's sort of like giving a patient with a broken finger a complete physical before you set the bone and apply the splint. Now, don't get me wrong. Tests are mighty important, and sometimes they are downright indispensable. But knowing what to test first is the most important of all.
On a performance complaint, a road test is usually the first and often the most important test of all. You'd be surprised how much time and trouble you can save yourself by identifying the complaint and then checking out the most likely causes in logical order. Why don't you give Tom some examples, Steve?
Good idea, Tack. Suppose an owner's only complaint is hard starting, cold engine, and cold weather. The trouble could be either electrical or fuel system. But by the time we get the car into the service department, the clues are apt to be gone. Here's how I'd go about locating the trouble. The first thing I'd do is test the battery and the cranking voltage. If the cranking voltage is low, the trouble is probably electrical or ignition rather than carburation. If cranking voltage is okay, the trouble is apt to be in the carburetor choke system.
That sounds like a practical example of diagnosis by the process of elimination.
It's a good example of how important common sense is and how much time you can save by thinking first and then testing. You got another example, Steve?
You bet. Suppose the only problem seems to be sluggish cold engine performance and perhaps frequent stalling until the engine is completely warmed up. Now, this sounds like fast idle and choke system trouble, and it may well be just that. However, a manifold heat control valve that is stuck in the open position could cause the same kind of performance problems until the engine is warmed up. So that's one of the first things I check on a cold engine performance complaint. Now, let's take a case of rough engine operation at idle speeds. No other performance complaints. What are the possible causes, Tom?
Gee, rough idle could be caused by ignition troubles, carburation troubles, or a cylinder or two having low compression. But what do you test or check first?
If you can't smooth out the idle by adjusting the idle mixture, but you can get an idle mixture that's too rich and a mixture that's too lean, the low-speed system isn't restricted. And there are some other things to check before you get deeper into the carburetor. For instance, check the crankcase vent valve. If it's stuck closed and plugged, it'll make the idle mixture too rich. If it's stuck open, the idle mixture will be too lean. In either case, engine idle will be rough. Another thing, check ignition timing. Just be sure you disconnect and plug the vacuum advance line.
And don't forget, narrow spark plug gaps can cause rough idle, too, without noticeably affecting engine performance at other speeds.
I was just getting to that, Tech, because if I hadn't located the trouble yet, I'd pull the spark plugs to check engine compression. Since low compression on a cylinder or two affects engine smoothness a lot more at idle speeds than it does at road speeds, rough idle may be a clue to valve or compression troubles.
I want to put in my 2 cents worth on another kind of trouble. A lot of fellas strike out on troubleshooting an acceleration stumble because they don't stop to think about the difference between the purpose of the accelerator pump system and the step-up system. Now, you see, the only purpose of the accelerator pump system is to feed the engine extra fuel when you step on the gas. This is a purely mechanical one-shot deal, and it only lasts for a few seconds. On the other hand, the step-up system is controlled by engine vacuum. It supplies extra fuel through the main metering system for good acceleration and high-speed performance. It operates when engine vacuum is low.
I get it. If you get a momentary stumble on acceleration from any speed, but the engine picks up the load and does its stuff from there on, the trouble is probably in the accelerator pump rather than the step-up system. Of course, if you get full power momentarily when you step on the gas, but your performance fizzles out as soon as you've used up that one shot from the accelerator pump, the trouble's apt to be in the step-up system.
Right, Tom. Now, here's the easiest way I know to check the accelerator pump. Remove the air cleaner and open the throttle quickly. A solid, continuous stream of fuel will be discharged into the air horn if everything's okay. On a two-barrel carburetor, be sure to check for equal discharge patterns in both barrels. We'll get into some of the fine points of servicing the accelerator pump system and the rest of the carburetor in a couple of minutes. But first, I want to cover a full-throttle, high-speed performance problem that's caused by fuel supply rather than the carburetor itself. The car acts like it's running out of gas. I've seen a lot of carburetors overhauled unnecessarily when the trouble was in the fuel filter or the fuel pump. Anytime I run into a high-speed, full-throttle performance problem, I measure the amount of fuel delivered through the filter in 1 minute while the engine's idling at 500 RPM. It should be 1 quart. If it's less, repeat the test without the filter in the line. If fuel delivery is okay, you have filter trouble. If fuel delivery is still low, the fuel pump, the lines, or possibly a restriction at the tank inlet is the cause of the trouble.
I think I get the idea. Be sure and identify the complaint. Next, use some mental diagnosis to figure out what could cause that specific kind of trouble. Test or check out all possible causes. You can save time by doing the easiest things first.
I couldn't have said it better myself, Tom. Now, I think Steve is about ready to explain some of the fine points of servicing carburetors. These are tips that'll help you correct trouble as well as avoiding building in trouble when you overhaul a carburetor.
Don't ever forget the importance of checking the float level on every carburetor job. A low float level setting is a common cause of stumble on acceleration. A high float level raises hob with fuel economy and aggravates hot start problems. We'll get into that later. Right now, I want to cover some important float level checking and adjusting tips. The synthetic tip of the float needle is easily compressed. This can cause a false float setting, which will result in a low fuel level when the tip regains its shape. To avoid this, invert the body so that only the weight of the float is seating the needle when you check the float level.
If you have to adjust the float level, remove the float to avoid compressing the tip of the needle.
That's a good point to remember, Tom. And here's another. Always put the carburetor throttle body on a repair stand to avoid damaging the throttle valves. That's important because if a throttle valve is misaligned or bent, both ignition advance and the amount of fuel supplied by the idle transfer port will be upset at idle, and it may be impossible to get a smooth idle and good low-speed performance. To check throttle valve alignment, back off the idle speed screw so you can close the throttle valve completely. Hold the carburetor up to the light to see if the valve clearance in the bore is uniform.
Make sure the bore is clean and there aren't any deposits at the fuel ports.
Good point, Tech. To realign a throttle valve, loosen the attaching screws slightly. Then, hold the valve closed with your fingers and tap it lightly to center it in the throttle bore. Then, tighten the screws. If you have to remove throttle valves or a shaft, be sure you mark the valve to show its position on the shaft. If you install the valves in the wrong bore or wrong position, you'll upset the calibration of the low-speed system.
Hold it, Steve. Someone better turn the record so we can hear what you have to say in the second half of this film. Now, what were you about to say, Steve?
Here's a point about throttle valves that's worth remembering. On 4-barrel carburetors, It's important to check the secondary throttle valves, too.
How come? There aren't any idle ports in the secondary bores.
Think about it a minute, Tom. If the secondary valves are misaligned or improperly adjusted, excessive airflow past the valves leans out the mixture and causes a rough idle. The engine may not run at all at normal idle speeds.
I guess I should have thought of that.
Don't let that worry you, Tom. Just remember the lesson. You're not the first one to overlook the fact that secondary throttle valve alignment and adjustment affects engine idle. What's next, Steve?
The choke piston, Tech. On every carburetor job, clean the choke piston, the piston cylinder, and the bearing ends of the choke shaft with carburetor cleaner. This is mighty good insurance against cold start troubles. You see, gum and varnish accumulations on the piston, in the cylinder, and in the choke shaft bearings hold the choke wide open, even though the choke rod is trying to close the choke.
The only stuck choke pistons I've seen were on real high-mileage cars.
Don't be fooled by a choke piston or shaft that doesn't stick when the carburetor's warm. Those gum deposits are not very sticky when they're warm, but they stick like glue when they're cold.
Where do those deposits come from?
When a hot engine is shut off, fuel vapors from the fuel bowl find their way into the choke piston cylinder and choke shaft bearing areas.
How long does it take to build up enough gum to cause trouble?
That depends on the fuel used and the type of driving. A treatment of carburetor cleaner at least every 6 months will help prevent the deposits from accumulating. In some cases, it's a good idea to do it every 2 months, when the engine oil's changed. Here's something I learned about chokes the hard way. A couple of owners came in complaining that they still had trouble starting after I'd cleaned the choke piston. This stumped me until I talked to one of the complaining owners. Here's what I learned. The owner had been pumping the accelerator to get his car started before I cleaned the carburetor. After I fixed the choke problem, he still pumped the accelerator every morning and had trouble starting because he was flooding the engine. Since that experience, the boss has been careful to tell owners who've just had choke troubles fixed to open the throttle enough to release the choke, but not to pump the accelerator.
It's probably a good idea to make sure owners understand how to floorboard the accelerator to unload a flooded engine, too.
Right, Tom. And speaking of chokes and the unloader, there's a lot more information on these two items in the reference book. We won't take time to cover them now because Steve wants to give you some pointers on adjusting idle mixture.
One of the most important steps in turning out a good carburetor job is adjusting idle mixture and idle speed for the smoothest possible idle and low-speed performance.
I've seen more than one carburetor job turn sour because the technician didn't take time to do the job right.
Be sure the engine is warmed up to normal operating temperature. When it is, the choke valve will be wide open. Setting the idle on a partially warmed-up engine is bound to cause trouble. Turn the headlights on high beam, and if the car has air conditioning, turn it on full blast. You want full alternator and compressor load on the engine when you set idle speed. On torque flight jobs, disconnect the throttle linkage to eliminate interference with the transmission.
Since high manifold vacuum is the best indication of a good idle mixture, use a vacuum gauge. And don't guess at idle speed. Use a tack. The right mixture at specified idle speed is most important.
Tech's right. And here's how to get the best idle mixture. Back out the idle mixture screw about 1 full turn. Adjust the idle speed screw to get the idle speed specified. That'll establish a starting point for balancing idle mixture and speed. Next, adjust the idle mixture screw slowly in or out to get the highest possible steady vacuum reading.
Adjusting the idle mixture will usually increase the idle speed, so readjust the idle to specified speed. This will move the throttle valve to the right location relative to the idle and vacuum advance ports.
That's important, because throttle position must be correct when you make your final mixture adjustment. Very carefully readjust the mixture screw until you again get the highest steady vacuum reading. If idle speed is picked up a bit more, readjust it.
Here's an important point to remember. The highest steady vacuum reading indicates a relatively lean idle mixture. With this lean mixture, the engine may stall now and then.
How do you compensate for that?
Increase the richness of the mixture slightly. Carefully back out the mixture screw a fraction of a turn. When the vacuum drops slightly, the mixture will be just rich enough to prevent stalling.
How about 2 and 4 barrel idle mixture adjustment?
On 2 and 4 barrel carburetors, adjust first one and then the other mixture screw. Readjust idle speed if it increases appreciably. Continue alternate adjustment of mixture screws and idle speed until you get the highest steady vacuum at specified idle speed.
Now, here's an important tip. If you have to open or close one mixture screw a lot more than the other to get the best vacuum reading, something's wrong. It may be damaged idle mixture screws, or one of the idle ports or passages may be restricted.
Good point, Tack. For your final idle mixture adjustment, turn both mixture screws out a bit and the same amount to increase the richness of the mixture slightly.
And don't forget, keep your eyes on the vacuum gauge. That slight drop you get when the mixture's a gnat's whisker rich means the idle mixture's about as lean as you can get it without running into stalling problems. Any questions?
I have one on fast idle. Since an engine that's warmed up isn't supposed to run at fast idle, why are fast idle specs based on warm engine speeds?
Adjusting fast idle when the engine's hot is the easiest way to get the right cold engine fast idle speed. In the first place, you never make any carburetor adjustments on a cold engine. In the second place, there's no practical way of knowing how cold a cold engine is, but a warmed-up engine is a definite known condition. By setting the hot engine fast idle speed right, you're sure the cold engine fast idle speed will be right, too. High enough to keep the engine running during warm-up.
Before Tech rings the bell on this powwow, there are a couple of points I want to clear up about hot engine starting troubles. The first thing I check is the owner. I make sure he's holding the accelerator down long enough to clear a flooded engine and isn't pumping the accelerator. Next, I make sure the external bowl vent is working and properly adjusted. I also make sure that someone hasn't set the accelerator pump on the longest stroke. On some carburetors, the bowl vent and pump stroke adjustment are made at the same time. On other carburetors, the bowl vent and the pump stroke adjustments are made separately. Check the manual for adjustment details on the carburetor you're working on. Float level is very important. A float level that's high can cause serious hot start problems, and a high float level won't help fuel economy a bit either. As a matter of fact, I've found you can reduce the float level 1/32 of an inch below specifications to minimize hot starting problems.
Don't lower the float too much, or you'll get into engine stumble and acceleration problems.
Tech's right, Tom, so watch it. I also inspect the float needle valve to make sure it isn't damaged, worn, or leaking. A leaking valve aggravates hot start problems. In extreme cases, I relocate the fuel filter to get it as far away as I can from an engine hot spot and position it upright instead of horizontal.
Why get the filter upright?
If the filter is horizontal, fuel expansion and fuel vaporization that takes place when the filter and fuel lines start to soak up heat from a hot engine pushes a solid stream of fuel through the carburetor and into the intake manifold. If the fuel filter is upright, or at an angle of about 45 degrees, the vapor cushion at the outlet side of the filter feeds vapor instead of fuel into the carburetor. This doesn't load up the manifold excessively.
The fuel filters have been relocated on all current production cars. If you want to know where to put the filter on a past model car to solve a hot start problem, just take a look at a late production job with the same engine and equipment. And speaking of late, it's later than I thought, and high time we wound up this session. For a sign-off, I'm going to steal Tom's lines and repeat what he said earlier. Be sure and identify the complaint. Next, use some mental diagnosis to figure out what could cause that specific kind of trouble. Test or check out all the possible causes. Finally, save time by doing the easiest things first. Those are the best lines I ever stole from anybody.